Early ARI history. The growth of computers and the emergence of AI are closely related. But before the creation of contemporary computers, the foundations of AI were laid. Animals were viewed by philosophers like Descartes as machines, and automatons were the forerunners of modern humanoid robots. However, the history of manufactured beings goes far older, to tales of the Prague Golem, or even further, to Greek myths like Pygmalion's Galatea. The work of McCulloch and Pitts, who in 1943 constructed mathematical models, called perceptrons, of neurons in the brain cells, based on a thorough investigation of the biological originals, is likely the source of the greatest direct antecedents. They demonstrated how neurons operate in a switching binary manner by either firing or not firing, being on or off, but they also demonstrated how such neurons may learn and subsequently alter their behavior with respect to time. British scientist Alan Turing was arguably one of the most important pioneers in the area. Turing made an attempt to address the question, can a machine think, in a seminal work he authored in the 1950s, which was written long before the advent of modern computers. At the time, it was revolutionary to even pose the question, but it was also extremely provocative to develop a useful test, often referred to as the Turing test, to provide an answer. Shortly after, Marvin Minsky and Dean Edmonds constructed what has been referred to as the first artificial intelligence, AI, computer, which was based on a network of McCulloch and Pitts neuron models. Claude Shannon also thought about the prospect of a computer playing chess and the kinds of tactics required to determine the following move. The first workshop honoring the emerging subject of AI was held in 1956 at Dartmouth College in the USA at the initiative of John McCarthy, Minsky, and Shannon. Many of the subject's later classical underpinnings were initially established here. The Middle Ages of ARI development. The General Problem Solver by Newell and Simon may have made the greatest impact on the field in the 1960s. This was a multipurpose program designed to simulate some human problem-solving techniques on a computer. Unfortunately, the method used was not especially effective, and the project was abandoned because it took too long and required too much memory to address even relatively simple real-world problems. The concept of fuzzy sets and systems, which allows computers to act in a manner more akin to that of humans by being fuzzy, was introduced by Lotfi Zadeh, who also made a substantial contribution in the 1960s. In addition to these instances, the 1960s may have been a time of some irrational assertions about the ability of AI to quickly replicate the whole functioning of the human brain. In retrospect, it's been noted that trying to make a computer function exactly like the human brain was akin to trying to make an aeroplane fly like a bird. In the latter scenario, one would miss out on the positive aspects of the aviation, and similarly AI research at the time was missing out on many positive aspects of computers. Unsurprisingly, some of the constrained thinking from the 1960s still exists today, which is unfortunate. Without fully taking into account the scope and exciting potential of various types of AI in terms of machines being intelligent in their own ways, not just replicating human intelligence, some current textbooks still focus solely on the classical approach of trying to get a computer to copy human intelligence. During this time, significant effort was made to enable computers to understand and communicate using human-like language as opposed to their simpler machine code. This was motivated in part by Turing's theories on intelligence, but it was also motivated by a desire for computers to more easily interact with the outside world using a few fundamental grammatical principles. The Dark Ages of ARI research. The 1970s proved to be somewhat of a letdown and, in many ways, was a dark age for AI after the excitement of the 1960s, with large research funding and boasts of what would soon be achieved in terms of AI mimicking human intelligence. When the predicted results did not materialize, some of the more idealistic 1960s statements led to extraordinarily high expectations, and a large portion of the funding for AI research vanished. But it must be remembered that compared to today, the capabilities of computers and by extension, AI programs, were extremely constrained in the 1970s. Even the finest programs could only handle simplified versions of the issues they were meant to address. In a way, all programs of the period were toy programs. In reality, scientists had reached a number of fundamental limitations that would not be overcome for a very long time. One of these was in particular, low computational power. Rosquillan's natural language computer, which had to make do with a vocabulary of only 20 words, is an example of this from the period. There was simply not nearly enough speed or memory for really meaningful jobs. The fundamental issue, however, was that even to function at a very low, restricted level, AI tasks like teaching a computer to interact in a natural language or comprehend a picture's content somewhat similarly to a human required a lot of data and processing power. As if the technical challenges encountered in the 1970s weren't enough, the discipline also started to attract the interest of philosophers. For instance, John Searle developed the Chinese room theory to demonstrate that a computer cannot be considered to understand the symbols it uses to communicate, which is covered in Chapter 3. Additionally, he contended that in light of this, the machine cannot necessarily be regarded as thinking in the sense of symbol manipulation, contrary to what Turing had before proposed. Although many practical researchers choose to ignore criticism and carry on with their work, certain philosophers, such as Searle, strongly suggested that the actual advancements of AI will always be severely constrained. These people misunderstand and need to be ignored, according to Minsky. As a result, there was a lot of internal conflict, which diverted attention from technical advancements to philosophical debates that many people today recognize as red herrings. John McCarthy believed, almost alone at the time, that human behavior and how the human brain works are not directly relevant to artificial intelligence. In his opinion, problem-solving robots rather than computers that think similarly to people are what the world really needs. This was criticized by Minsky, who maintained that for a computer to grasp objects and communicate effectively, it must think like a person. The discussions continued, and so on.